In the previous video we looked at limited liability as a factor of risk-taking in financial markets. And the idea was that even though a project may have a negative expected value, if you increase the variance or the risk of the project enough with limited liability, the project actually becomes profitable. So limited liability is something that works at the company or the bank level. But something similar is going on at the employee or let's say the trader level for employees in banks. And here the point is that firms in general and banks cannot pay negative wages to their workers. So there's a limited liability in the sense that the wage has to be at least equal to 0, and it's usually higher than that. Now there was this general idea that the reason why banks were using these bonus contracts, which increased risk-taking by traders, was caused by the fact that there was vigorous competition among banks to attract the best traders. But that reasoning is not completely clear, because if you want to compete for the best traders, why not pay them a high base wage? There is no reason why you should pay them actually a bonus. So in this video we're going to look at this phenomenon that competition among banks for top traders caused them to pay high bonuses and in that way induced them to take risks. And the explanation that we're going to be looking at is modeled as a combination of moral hazard and adverse selection. So in the video on asymmetric information we looked at moral hazard and adverse selection separately. Now we're going to combine both, and this is based on a paper by Bijlsma et al. In the Rand Journal of Economics in 2018. The idea is that when a trader invests in stock or another investment opportunity, there are going to be 3 states of the world. So the outcome can be good, the outcome can be average, or the outcome can be bad. Yeah, so the profit of the bank is going to be high in the good state, it's going to be average in the average state, and it's going to be negative in the bad state. Now in the bad state, the bank is going to pay its trader a wage equal to 0. So if the trader invests and the returns on the investment portfolio are really low or even negative, we assume that the bank is going to pay a wage equal to 0. In the average state, the bank is going to pay a wage equal to W, which is going to be at least equal to 0. And then in the good state, the bank may want to give a bonus to the employee which exceeds the wage in the average state. So this will capture the moral hazard part of the story. These wages will determine the risk of the portfolio that the trader will select. The adverse selection part is modeled by the talent of the worker, and that we capture with a parameter alpha, which we assume is going to be smaller than a half. Oops, sorry. So the talent of a trader is modeled by alpha. Higher alpha means that a trader is more talented, but alpha is always going to be smaller than a half. Now the investment that is chosen by the trader will put a probability Q on the average state of the world. And there's going to be a probability of alpha times 1 plus Q times 1 minus Q on the good state of the world. So this is the probability that the good state of the world will appear. And then finally, the probability on the bad state is going to be given by the following expression. It's 1 minus q, which is the probability of the average state, minus the probability of the good state of the world. Yeah, so I'm cheating here a bit because here I'm using an emacs feature that's actually not there in the Jupyter notebook, which allows me to make some calculations actually in the notebook itself. It's called calc. If you want to do the same in the Jupyter notebook, you can actually look at the package SymPy, which stands for symbolic Python. But that's not a package that we actually look at in the course. So if you want to go along with the derivations that I'm doing here, you can simply write them down because they're not going to be very difficult. So this is the probability in the bad state of the world. So let me just duplicate this expression so we can play around with it. So the thing I want to know is that, if I increase q, what is going to happen to the probability of the bad state of the world? So the way I can do this here is that I actually take the derivative of this probability with respect to q. And then what you can see is that because alpha is smaller than a half, 2 times alpha is going to be smaller than 1. Q is a probability, which is also smaller than 1, so this thing here is negative. So that means that if I reduce the probability on the average state of the world, I'm going to increase the probability on the bad state of the world. So reducing Q actually implies taking more risks in the sense that I'm increasing the likelihood of a bad outcome. So the next thing that we want to know is what is the optimal Q that is going to be chosen by the worker. And for this we need to look at the worker's objective function. So that's going to be given by the following expression. So with probability Q, we end up in the average state of the world, and then the worker gets the wage W. And then we have this probability, which is equal to alpha, which is the talent of the worker, times 1 plus Q, times 1 minus Q, times the bonus. So this is the probability of the good state of the world. And in that case, the worker receives a wage B. So the worker objective is this expression here. Again, I can duplicate the equation to play around with it. So the first step that we're going to do is we're going to take the derivative with respect to Q of this expression. So look at the first order condition to see what the optimal choice of Q is for the worker. So we differentiate with respect to Q, and then this is the expression that we get. So this is a fairly simple expression, and we can actually solve it with respect to Q. And we can display it like this. So basically what we see is that the worker's choice of the probability of the average state is determined by this ratio W over B. And this ratio, we're actually going to give a name, so we call it R. So R is going to be equal to W over B, which means that the lower R is, the higher the bonus is compared to the base wage rate. And as we can see here, when R goes down, so B goes up compared to W, the worker is going to choose a higher and higher risk. It's going to be more risky, the choice is going to be more risky. Q is going to go down, so the probability on the average state goes down, which means the probability of the bad state goes up. And this alpha here is the talent of the worker. Now the thing we're interested in is this outside option, which we're going to denote by O. Because the argument was that banks were competing more vigorously for these top traders. So that means that top traders had better outside options when the banks were competing. So what we're going to be interested in is what is the effect of this outside option on R, on the ratio of the bonus compared to the base wage. So the bank is going to pay the trader something that's going to be equal to the outside option. It has to compete with the other banks. So what is the expected payoff for the trader if it accepts the contract of this bank? It's going to be equal to R times B times Q. So that basically is the base wage W times Q, which is the probability of the average state of the world. And then we're going to get B times the talent of the worker times 1 plus Q times 1 minus Q. Yeah, so here we have the expected wage for the trader if it accepts the contract given by this bank, and it has to be equal to its outside option. So the question is, when we increase the outside option, how is the bank going to react? Is it going to increase W, or is it going to increase the bonus? So what we're going to do here is we're going to solve this expression. So first let me duplicate the expression, and now I'm going to solve it for B. So the bonus that the bank is going to give is going to be given by the outside option divided by the expression below here. So we need one final ingredient, which is the incentive compatibility constraint for the load type. So what's that going to be? So if the load type simply reveals himself as being a load type, is going to be paid a wage rate given by WL. But if the load type starts to mimic the high type, so it claims to be a top trader, simply to catch these high salaries that top traders earn, it's going to be a probability QL that we end up in the average state of the world, and then the load type is going to receive this base wage W. That's the wage of the high type, so the top trader. Then the talent of the load type is going to be denoted by alpha L. I'm going to choose values for alpha of the high type and the low type in a second. So we're going to multiply this by QL plus 1 times 1 minus QL times B So to make sure that the load type works as a load type trader and not claims to be a high type trader, it has to be the case that the wage I'm going to pay the load type is equal to the expected wage that he's going to get if he's going to behave as if he is a top trader, as if he is a high type. The exact choice of Q by the load trader, when he reveals himself to be a load trader, is actually going to be efficient. There's no reason to distort that choice, and that actually means that I don't need to model it. Finally, we're going to assume that the types are going to be distributed 50-50. Yeah, so half of the traders are top traders and the other half of the traders are average traders. So now we're going to start with the Python code. So what we're going to assume is that the talent of the low type is going to be given by 0.1, and the talent of the high type is going to be given by 0.5. The earnings of the bank in the average state are going to be equal to 1. The earnings of the bank in the good state of the world are going to be 10. And the earnings of the bank in the bad state of the world is going to be minus 20. Yeah, so these payoffs in the different states are given. What's endogenous is the probability that the trader is going to put on these different states. And that choice by the trader is going to determine the profit of the bank. So that's going to be a function of R. This is the thing that we want to know. How risky is the wage schedule going to be? So the fraction of the base wage and the bonus. And it's going to depend on the outside option O. So let me do this like this. So QH, so the choice of Q by the high type is going to be equal to, so we're using the expression over here, and we're using that R is equal to W over B, so it's going to be given by R divided by 2 times alpha H. If the low type mimics the high type, the low type is going to choose R divided by 2 times the talent of the low type, which is given by alpha L. The equation for the bonus is the one we derived here. This is the expression for the bonus, so we're going to give that here as well. So that's going to be the outside option divided by R times QH plus alpha H times QH plus 1 times 1 minus QH. The base wage is basically R times B. This is simply the definition of R. And then finally we have that the wage for the low type is equal to QL. So the Q that is going to choose if it mimics the high type. So now with probability QL is going to earn this base wage. And the probability of earning the high wage is alpha L, its talent, times QL plus 1, times 1 minus QL times B. Yeah, so this is the probability of the average state of the world if the low type mimics the high type, and then it earns the base wage. This is the probability for the low type when it's mimicking the high type of getting into the high state of the world, the good state of the world, in which case it gets its bonus B. So then the profit for the firm is going to be, with probability 0.5, it's going to be dealing with a high type. And if there's a high type, its profit is going to be QH. That's the probability of the average state of the world when you meet a high type. There's going to be the probability of the high state of the world, which depends on the talent of the high type, which is alpha H, times QH plus 1 times 1 minus QH. And in this situation, we're going to earn YG, which is the profit for the bank in case of the good state, which is going to be 10. And then of course with probability 1 minus QH minus the probability in the good state of the world. So that's going to be this. So this probability here is the probability of the bad state of the world. It's 1 minus the probability of the average state minus the probability of the good state of the world, so that's the complement of it. So in this case what's going to happen is that the bank receives the return in the bad state of the world, which is going to be minus 20. And of course the bank has to pay an expected wage to the high type, and that expected wage is exactly equal to the outside option of the high type. Then there's a probability of 50% that the bank is going to meet the low type, and the low type has to be paid a wage WL. The low type will also hopefully generate a profit for the bank, but actually we can ignore it here because it's not going to be distorted. So we don't need to worry about it. The only thing we need to worry about here is the wage it has to pay the low type. So this function now will return profit. So we're going to maximize profits. So we have an initial guess that we're going to need. Let's say that's 0.5. So we use from SciPy optimize, and we're going to minimize minus profits. So we're going to define a lambda function, which is going to be minus profit as a function of R. That's the thing that I want to know. And let's first calculate this for an outside option equal to 1.0. And we need the initial guess. Initial guess. So here we are. So let's see whether we didn't make any mistakes. No, we didn't. So this is calculated. So what we see is that in this case, there's going to be an R of approximately 0.6. So now let's calculate this thing again. And let's assume that the outside option has doubled, so now it's equal to 2. And what we see is that instead of 0.6, R is now going to be 0.5. So recall that R was defined as W divided by B. So what we see is that when we increase the outside option from 1.0 to 2.0, R is going to fall. It's going to fall from 0.6 to 0.5, which means that the bonus increases compared to the base wage. So indeed here what we have modeled is this idea that as banks were competing more and more for the high type traders, meaning the outside option increased for the top traders, when this competition intensified and this outside option went up, it became optimal for the bank to pay more bonuses compared to the base wage, and that again induced these top traders to take more risks.